go ahead and open a new Colab notebook. We are going to do a quick classification that doesn't have multiple outputs. And so we'll just call this straight keras classification. And you should have a URL provided to you in this one. So go ahead and put that in. If you don't for any reason, I can quickly show you. So on my GitHub page, actually it's not mine, sorry, you can find mine, but there's a packed publishing, you don't even need that. If you just type on hands-on, it's a load full. Hands-on gradient boosting with XGBoost and scikit-learn. Oh my goodness. Didn't spell scikit-learn right, but you'll get a GitHub page. There's a book that I published. And in chapter 2, there is a heartdisease.csv is what we're looking at here. So if I click on heartdisease.csv, this is how you can access files in GitHub. Okay, this won't work, but if you simply click on view raw, okay, now this is going to work. So you copy and paste that in there. That's the correct URL. Okay. Yeah, because I like to do less of like, oh, you've got to have the link, and more like, let me just show you how to get it where it is, because this will work for actually any GitHub CSV file. You got to click on that raw. Okay, it's the wrong notebook. You see there it is. Same info. Okay, let's load it up. So how do we do that? Import pandas as PD. df equals pd.read_CSV. And parentheses up there. And then I need to put the URL in there. And now df.head. So look at it. I was going to see your data, make sure it is what you expect. Otherwise you can get stuff that's just crazy and because you loaded the wrong data. Okay, so what this is a nice little heart disease data set. It actually, you're using this information about people to determine whether they actually have heart disease or not. And you can see that the target, I mean, these are all ones, but they're also zeros. Because this is very standard, and the goal is to predict 0 or 1. I think what I want to do here is, let's just code it up properly. So from sklearn.model selection, import train test split, and underscore split. Let's go ahead and split it. So, I don't have X and Y. I do this often, jumping the gun. What's X and Y? X equals df.iloc, all rows, all columns leading up to the last one. And Y equals df.iloc, all rows, just the last column. And now I can split it into X and Y, right? So X train, X test, Y train, Y test for tuple equals train test split. If you're like, what's a tuple? It's just like whenever you have more than one value, but it's not a list. The difference between like a tuple and a list, they're very similar. Let's go ahead and try to run that. Is that tuples are not changeable. Okay, that's the main difference. But it's just a sequence of 4 numbers that you can access via index. Okay, so let's do keras now. We could decide, like, do we want to scale it? We got better results with scaling, why not, right? Let's try that scaling again. So I still have the link up, the min-max scaler. And then remember how I was saying you can do it in like one step. So maybe I'll even copy that in there this time, right? I'm saying both is useful, copying code and rewriting it. So go back to the Colab notebook. We need to import the min-max scalars. So usually if I go back, I said I didn't copy everything. Usually you're better off. The inverse, by the way, which you see down there, is basically like if you want to go in the reverse direction, which is incredibly great. All right, get it in there. Too much going on. There we go. We already loaded the data. And it's in here twice. So what are we going to put in here? Demonstrate data normally. Okay, so it's the X, right? X train. If you have X train, you got to do it for X test, okay? X train, you do it for X test, right? Otherwise, the model just won't work well. Okay, we're almost home through. This one's going to run really quickly because it's a small data set. And, really deep learning is designed for big data. But we just want to see, how does classification work? Well, what I think I'm going to do here is copy the regression code and show you the differences for the sake of time. So here's all this regression stuff. Let's copy that in and see, what do we need to change here for classification? Okay, let's look at it. Okay, we've got sequential model, DINTs. We can use dropouts, early stopping. We want to take the number of columns for X, start with sequential, activation ReLU, okay. You can mess with the layers, but we'll do plenty of that in this course. But for now, it's just 3 hidden layers of 8, reasonable, right? It's fine. Now, when you compile it, this is where it's got to shift. So, okay, you could still use an optimizer of Adam, but that loss is not right? That's for regression, mean squared error. Before I categorical cross entropy, let's do binary cross entropy, okay? That's when you just have 2 outputs. And then metrics equals accuracy. Oh. One other key little piece here. It's this last one, the output layer. So it is actually going to one output layer, even though it splits into 2. But it does it with the sigmoid, okay? Because when you do that, when you put activation equals sigmoid, what it's going to do is it's going to force it to choose between 0 and 1. So that should do it. I think everything else is okay. The scoring model, right? That's not what we want. We don't want an RMSE. You can just do model.evaluate, and I think it by default will give you the accuracy. But important, we put our metrics equals accuracy in there, and that should actually be in a list, okay? So I think those are all the key changes. I think this looks okay. Let's give it a whirl. I always feel like whenever I change code, write code like this amount, I say let's give it a whirl. I'm like 50-50 whether there's going to be an error or not. That's just the way it goes with coding. It shows number of parameters only 265. And now let's see how the model, like with what speed the classification model performs, to see if we're going to wait for it to deliver a score. It's fast. Yeah. And you can see that, you're getting pretty good accuracies. The validation accuracy, look here, is higher than accuracy, so that's interesting. And wow, see that quickly got a score back of 83%. I can tell you that's a decent score on this. This one is hard to do. Let's just quickly see if we can do one more thing. I mean, you could just say, like, 'cause we have a lot of these 4i in range, and pick how many of these you want to do. Like, so should we do 8? But find anything? And basically, we just do this each time. Add new layer. And you've got to be sure how to add I, right? Wait, you don't have to, I'm sorry, you don't have to add I for this. I think I did that previously, but that's, because it's just going to go through 0 to 8. And then you've got to keep the output layer, right? So in effect, you can do loops for your middle layers, but your kind of initial layer and your output layer have to be special because you need the input shape set and you need to be sure you have the right activation here. Okay, try that one more time, a bit longer. And again, our goal here is not right. I sometimes just like to see if I can do something to make it better. Goal here did not perform better on the test. Like, interesting. I think it's something about the test set because like the validation accuracy was strong, as was the accuracy. So that's interesting. And again, I'm not going to mess with that now, right? We already did the train test split. The goal is not to work in this data set. You could do it for fun if you want. The goal is simply to see, okay, now I understand how classification works of one single or like a binary output. So that concludes our introduction to keras. We've done a lot. We looked at how to use keras for the MNIST data set with multiple kind of outputs. Okay, we looked at some refinements and advancements that we can make to keras to make stronger models, get better scores. And we took a look at also how to use keras for regression classification. Why do I do that? It's for the sole purpose of being complete, so that if down the road you're doing classification or regression straight up, like, yeah, but I want to do it with deep learning. I don't, we did a little differently in the BCA program. Well, now you have these notebooks that you can refer back to. Okay, keep it up.